In terms of academic background, my degree is in natural sciences, so a bit of physics, a bit of chemistry, a bit of geology. My doctorate's in geology. So I've got a diploma in economics as well since then. And then in terms of the commercial world, I've really worked as an industry analyst really for the past 20, 25, almost 30 years now. Just looking at how industries, particularly technology industries, develop, what makes technologies competitive, what drives kind of technology change. And so advising companies on where the market is going, what the risks to their business are going to be, what the opportunities for their business are going to be as well. And then in recent years, I've done quite a lot of training work. In fact, much of what I do nowadays is kind of business education, I would call it, as much as training. It's kind of, again, helping people understand where things are going and what technologies they need to look out for and why. The decarbonisation agenda has obviously been around for a long time. So kind of social awareness has been higher, social concern is higher. But really what drives business, of course, is policy. There are a lot more countries now that have commitments to net zero targets, for example, in some cases legally committed to those net zero targets. So that obviously drives the framework in which business works. And then over the last few years, one thing that's obviously come up, particularly the last year, has been the whole energy security side of things. Just a desire in many countries to get away from dependence on having to import fossil fuels, having to be dependent on energy from elsewhere, and looking at domestic sources, looking at things like renewable power, renewable sources. How can they sort of have a system which is not only cleaner but potentially cheaper? We've seen costs come down dramatically in things like solar and wind and battery, but also sources that are just more resilient, more reliable, more in their own control. To get to net zero, or to get even to just lower carbon systems, even if you're not aiming all the way to net zero, it's not going to be one solution or the other. I think that's a mistake that many people seem to make, or certainly the way the press reports it. Often it's kind of, well, it's this against that, it's one solution or another. It's going to be a mix in the same way that the energy system today is a mix. I suppose there's some key trends we can pick out though. One key trend is it's going to be more about electricity than fuel. So there's the drive towards electrification of transport, electrification of heat as well. So obviously we've got to generate electricity. The cheapest ways to do that, at least at the power plant level, are going to be increasing your renewable sources. That also gives advantages that you're not dependent on fuel. It means that there's quite a big economic change there between. It's all about upfront cost, but then no fuel cost. There's no kind of fuel risk going forwards. But of course, to balance those renewable sources was also a lot more focus these days on flexibility. And so flexibility means basically how do you fill the gaps? How do you balance supply and demand with a classic kind of when the wind's not blowing or the sun's not shining? And so that's going to cover a whole bunch of different things. Storage, which most people associate with batteries, but actually there's a whole bunch of other solutions other than battery that are out there. It means there might be some occasions when we do need fuel that we can store on a large scale. That might include things like hydrogen. Hydrogen also then starts to overlap between the energy business and the chemicals business, because hydrogen really is a chemical reagent at the moment. But also, again, where it's difficult to get away from using fossil fuels, it brings in things like carbon capture and storage as well. So there's a lot of things on the supply side, but then there's also the whole demand side of the picture. People often think about that as reducing demand. I would actually say, yes, energy efficiency and reducing demand where you can is excellent. It's obvious, it's a kind of no-brainer to do. But there'll also be quite a lot around kind of shifting demand, just using things at more optimal times, for example. It will also include reducing demand for things like raw materials, so more kind of circular economy approaches, more reuse, recycling approaches. We can use captured carbon instead of carbon drilled out of the ground to produce products in future. It depends on a global level. The system is obviously still very much dominated by fossil fuels, although equally on a global level, the fastest growing new sources of electricity, for example, are renewables. Something like 85 or 90% of new power generation capacity that was installed last year was renewable, mostly solar and wind, solar being the fastest growing. That's not always reflected on the energy level, of course, because you need more capacity of certain things than you do with others to generate the same amount of energy. But the general trend is towards kind of new developments being cleaner. So that's one aspect of it. The UK has really been a good example of a very rapid transition. We've almost got rid of coal generation. We still need some of that around, particularly at the moment with the gas situation for backup. But we've gone from a system where we were burning probably kind of 35, 40% coal even 10, 15 years ago, down to almost nothing now. We generate about a third of our electricity from wind, for example. We still rely on gas, of course, due to the flexibility, so that's another challenge. So we've been very successful around the world in terms of growing renewable power. We're just starting, really, I would say, on the journey towards electrifying vehicles, increasingly kind of exponentially growing percentages in terms of new sales. We've gone, again, in markets like Europe, further forward countries like the UK, like Germany and so on. We've gone from car electric vehicle sales, for example, down at 1 or 2% just a few years ago up to 20-25% today. So we've got to go from where we were to this new system kind of tomorrow. Again, I think the term energy transition, the key word there is transition. It's going to be, there's a lot of work to do. There's a lot that needs to change to get to a fully clean system, however you want to describe that. But the uptake is really very, very rapid if you look at particular technologies. And as I say, renewables I would point at, electric vehicles I would point at, energy storage, the growth of battery technology has been, and deployment is just, again, exponential at the moment. The best place to start is to go to the IMechE website, the energy website. We've tried to put together, hopefully, a good mix of courses there, but also courses which are looking at the right topics, but also putting those topics in the right context, which helps businesses, helps engineers as individuals as well understand where the market is going, but beyond kind of the hype of where the market's going, what some of the challenges are. Engineers are all about solving problems and addressing challenges, and so hopefully if you go to the IMechE website and look at some of the courses there, what you'll find is content which is all about, on the right topics, are going to help you understand where's this going, how quickly might it be getting there, but in particular, what are the challenges, to get there, what challenges have to be done, because that's exactly what engineers, of course, can offer to the system.